Hello everyone, welcome back. I figured our last lesson was a lot of reading for you guys because you had to work your way through the slides on your own. So I figured I'd make this lesson as short and video oriented as I could. We have been learning about the slope-intercept form of a line. That's this part right here. Y equals mx plus b, where m represents slope and b represents the y-intercept. And basically this is your formula for writing a line. If you know its slope and you know its y-intercept, you can make it into an equation. So we worked on that from graphs first. That's what we did over here. So on this graph, if I needed to find the slope, I had two ways I could do it. I could either count and find the rise over the run, or I could set it up using the slope equation between any of these 2 points and find the slope. On this one, I think it's easiest just to count. So if we're looking at the slope of this line, I see that my rise is 2 because I go up from here to here until I'm directly opposite this other point. So my rise is 2, and then when I go over, I notice I went over just 2, so my slope is 2 over 2, and I would simplify that to just 1. So my my slope, is 1. And then my y-intercept of this line, which is represented by b, that's where the purple line crosses or touches the y-axis, which is up and down. So I see that is right here, and that point, if I were to write it down, would be 0, 2, because the y value right there is 2, but the x value is 0. So my y-intercept is 2. So if I wrote the equation for this line, it would be y equals 1x plus 2. I took this formula, I replaced my slope, and I replaced my y-intercept. Something important to note about this, your y-intercept is always where x equals 0. That value is where you find the y-intercept in any table or any ordered points. So if you saw, for instance, something like this, all right, I've got 2 zeros in here, but I only care about one of them. I care about where the x is 0. That gives me the y-intercept. So right here, my y is 0. That is not my y-intercept. Right here is, because that's where the x is 0. So if I put this on the graph, what I would end up with is at this point right here where y equals 4, x equals 0. That is my y-intercept. So we're going to use that information today to find the equations for these tables. So on our first table, over here, I've got 4 points where x equals -3, y equals 10, where x equals 0, y equals 12, and so on. So I need my slope and I need my y-intercept. Now remember, my slope is rise over run, or the change in y over the change in x. So here are my y values. I'm looking for what the change is. What's the pattern? From 10 to 12, it went up by 2. 12 to 14, it went up by 2. 14 to 16, it went up by 2. So my rise would be 2. And then I look at what's happening in my x's. -3 to 0 went up by 3, 0 to 3, and 3 to 6. So my slope is my rise, what's happening in my y, over my run, what's happening in my x's. So my slope is 2 over 3. So m equals 2 over 3. Now I just need my b, my y-intercept. So like we just said over here, the y-intercept is where x equals 0. So x equals 0 right here, but I need the y value at that point. And the y value is 12. So b equals 12. That's my y-intercept. So to write my equation like this, y equals 2/3 x plus 12. That's it. So let's take another example that's slightly, the example I had wasn't the best one, so I tweaked it just a little. Okay, we want to find the equation for the data that would form this line. So we're still using this, y equals mx plus b. We're going to start by finding the slope, the m. So that's the change in y over the change in x. So looking here, we know that y will always be the right column and x will always be the left column whenever we have a table. So these are my y values, and I can see that they're going down. They started at 200, then went to 150, then went to 100. So each time it's going down by 50. So that's the top part of my slope. And then the bottom part is what's happening in the x's, or the run. 1 goes to 2, 2 goes to 3. So it's going up by 1 each time. So my slope is negative 50 over 1. The other part I need is my y-intercept. And we said earlier that the y-intercept is where the line crosses or touches the y-axis, and that point is where x equals 0. Looking at my table, I don't have x equals 0, but I do have enough information to figure out what x equals 0 would be. So if I had 0 right here, 0 to 1, that's a plus 1, so that continues the pattern. Now I gotta continue the pattern on the other side. It was going down by 50 each day, 200, 150, 100. So to go backwards, in order for this to still be minus 50, I need 50 more than this one. So it would have been 250. 250 minus 50 gets me 200. 200 minus 50 gets me 150. So I know I'm right. I found the right value to maintain this pattern. So my b, my y-intercept, is 250. Now putting it all together to write the equation, I have y equals m negative 50 over 1 x plus my b value is 250. That's the equation for this table. Now lastly, you should see over here that this table looks a little bit different than the other two. It's horizontal rather than vertical. Tables like this do exist and you will encounter them. The only thing you need to remember here is that x values are on top. So the hour is x, the distance is y. So to find my slope, I look at what's happening in this bottom row in my y's. 0 to 40 is plus 40, 40 to 80 is plus 40. Then I look at my x's. 0 to 2 is plus 2, 2 to 4 is plus 2. So my slope is my change in my y's, 40, over my change in my x's, 2. So 40 over 2. And I go ahead and simplify. 40 divided by 2 gives me 20. So my slope is 20. The last thing I need is my b value. That's my y-intercept. That's where x equals 0. So where x equals 0 is right here. And I notice that at that place, y also equals 0. So my y-intercept is just 0. When I go to write my equation, y equals mx plus b, so 20x plus 0. Now I should notice that plus 0 doesn't actually change anything. So mathematicians like to be as efficient as possible. And that means we wouldn't even bother writing plus 0 because we know it doesn't make any difference. So y equals 20x would be the equation of this line. All right, your practice is going to be to try a couple just like this, and to make sure that no matter what shape I give you the equation in, you can identify both the slope and the y-intercept. So for instance, lots of times you might see something like this. This, even though it's not in the same order as this, is still the same thing. So if I give you this and I ask you what's the slope, well, the slope is what's attached to the x. And notice we've got a subtraction sign. So the slope is negative 3. And our y-intercept would be positive 4. So your practice is going to be write a couple of equations from tables like this and identify the slope and the y-intercept in a couple of equations like this. See you next time.